let's talk about one of the biggest, problems in agentic AI today. It's memory, or more accurately, its lack of one. It's this bizarre paradox, right? We've got these super powerful systems that can do incredible things, but they have the memory of a goldfish. But don't worry, we're not just going to talk about the problem. We're going to dive into a really elegant solution that could finally give AI a proper long-term memory and honestly unlock its true potential. So let's get right into it. I want you to just think about this for a second. What if an AI agent had a perfect memory? Imagine working with an AI that remembered every conversation you've had, every single task it's ever done for you, all your preferences, like a truly great colleague. It sounds so simple, almost obvious, right? But that's just not how most of these AI agents work today. And believe me, this one limitation is holding them back in a huge, huge way. Okay, so first things first, let's be super clear about what we're even talking about here. We're talking about agentic AI. Now, these are not your everyday chatbots, not even close. We're talking about autonomous systems that are built to actively do stuff. Write code, fix problems in your IT systems, handle really complex, multi-step jobs all on their own. All right, so to really get why these powerful agents aren't taking over the world just yet, we need to dig into their biggest flaw. And it's a simple one. They're just incredibly forgetful. So here's the absolute heart of the problem. An AI agent is what we call stateless. What that really means is its entire working memory, everything it knows about what it's doing right now, is crammed into this tiny temporary space called the context window. The best way to wrap your head around this is with an analogy we all get. The context window? It's basically like your computer's RAM. It's super fast, which is great, but it's totally volatile. The second that session ends, or heck, even when the window just gets full, poof, the agent's memory is wiped clean. It forgets absolutely everything. What it desperately needs is a hard drive, some kind of stable long-term storage. Now, I know what some of you are probably thinking right now. Hey, wait a minute, what about RAG, right? Retrieval Augmented Generation. And you're right, that's a technique that's supposed to help with exactly this problem. So here's how RAG works in a nutshell. It connects the AI to a big database of information. The agent can then ask questions, search that data, and pull the important bits into its temporary context window. And look, this is awesome for getting existing information into the model. It absolutely solves the input problem. But that's only half the battle. And here's why. RAG is, at its core, a read-only tool. It's fantastic at helping the AI look up facts that already exist. But it does absolutely nothing to help it remember the new things it creates. It doesn't solve the output problem. So that brings us to this really critical practical question. Let's say your agent writes a killer Python script, or it figures out this brilliant plan to fix an IT incident. Where does that work actually go? I mean, think about it. With just that temporary context window and a read-only database, the answer is, nowhere. It just vanishes into thin air. And this, right here, is exactly where this idea of agentic storage comes into play. This is the hard drive we were talking about, the one that these agents have been missing all along. But look, we're not just talking about giving an AI a network drive to save some files. That's not it at all. True agentic storage is way more sophisticated. It's a storage layer that's been designed from the ground up to be, aware of the agent. It understands that it's working with an autonomous system. Okay, so how do we actually make this happen? How do you give an AI access to all the different kinds of storage you have in a company? Object storage, block storage, you name it, without creating just a complete and total mess? Well, the answer is a universal language, a standard. I mean, think about the challenge here. The brute force way would be to write custom APIs for every single storage system. And trust me, that would be an absolute nightmare to maintain. You'd end up with a custom integration for your object storage, then another totally different one for your block storage, another for your network storage, each with its own weird API and its own quirks. It's just a tangled, messy web that absolutely, positively does not scale. But thankfully, there's a much cleaner, much more elegant solution that the industry is starting to rally around. It's a standard called the Model Context Protocol, or MCP for short. And the architecture here is actually beautiful in its simplicity. You've got the MCP host, that's the AI agent itself. Then you have the MCP server, that's your storage. And right in the middle, connecting them, is the MCP protocol. Think of it like a universal translator. The AI only needs to speak one language, MCP, and the protocol handles all the messy work of translating that to all your different storage systems. So MCP really boils down to two simple but incredibly powerful ideas. First, you've got resources. Think of these as just passive bits of data, the contents of a file, a record from a database. The agent can ask for these to get context, kind of like how RAG works. But then, and this is the game changer, you have tools. These are actual functions the agent can call, like list directory or, and this is the crucial part, write file. Okay, let's stop for a second, because I can almost hear the alarm bells going off for all the security folks listening right now. And you know what? You're right to be concerned. Giving an AI write access to your company's data? Yeah, that sounds pretty risky. And you absolutely should be asking that question. I mean, we're literally talking about giving an autonomous system the keys to the kingdom. One little hallucination, one misinterpreted command, and it could be catastrophic. This is exactly why safety can't be some add-on at the end. It has to be baked in from the absolute beginning. So, agentic storage isn't just about enabling write access. It's about enabling safe write access. And the way we get there is with 3 core layers of security. When they work together, they create a system you can actually trust. Okay, let's break these down. The first layer is immutable versioning. This is simple but brilliant. Every time the AI writes something, it creates a new version instead of just overwriting the old data. This means nothing is ever really deleted. You get a perfect audit trail and you can roll back any change instantly. The second layer is sandboxing. This basically puts the AI in a digital playpen. It can only operate in a very specific, constrained environment. So if an agent's job is to clean up log files, sandboxing makes it physically impossible for it to ever mess with, say, your critical system files. This completely solves something called the confused deputy problem, which is just a fancy way of saying you can't trick a trusted program into doing bad things. And now for the third layer, which honestly I think is the most fascinating one of all, intent validation. This is where the storage layer itself can turn to the AI right before it does something big and basically ask, hey, hold on. Why are you about to do this? And here's the cool part. Because large language models are fantastic at explaining their reasoning, the AI can actually answer back with its logic. It can say something like, my reason for this is that I'm deleting files older than 90 days, which is what the established retention policy says to do. The storage system can then actually check if that's true before it gives the final okay. It's a fantastic check and balance. So when you put it all together, by finally giving these agents a real memory with agentic storage and then wrapping it in these smart safety guardrails, we're knocking down 2 of the biggest roadblocks that have been holding agentic AI back. Which, of course, leaves us with one final and really exciting question to think about. Once our AI colleagues can actually remember and learn and act safely in our digital world, what are we going to ask them to build for us next?